In this video, we're going to be talking about scientific notation. Before we look at a few examples, I first want to talk about scientific notation format. So we're going to go ahead and look at this foldable first. So looking at this foldable, this is how we write numbers in scientific notation. So here, the number in front of your decimal has to be a number that is 1 through 9. Notice how I did not include the number 0, and I also did not include numbers that were larger than 9, like 10, 50, 100. This has to be a single digit. So again, that means only one number in front of the decimal. Again, that number has to be 1 through 9. Now, also important to note is your exponent. So if you are going from scientific to standard, if your exponent is positive, if you have a positive exponent, this means you're going to move your decimal to the right. So you will move your decimal however many times to the right this exponent is. Now, if your exponent is negative, this means that you will move your decimal to the left. Now, another important thing that we also need to talk about is whenever we are going from standard notation to scientific and what this exponent will be. So, if you have a big number, this means that you should have a positive exponent. If you have a very small number, so small number meaning less than 1, this means you will have a negative exponent. Okay, so this is also very important to note when you are going from standard to scientific. So with that being said, let's go ahead and look at a few examples of going from standard to scientific first. So we're going to start off on the left side of our foldable. We're going to look at problems 1 and 2. So for number 1, it says the approximate average distance of Neptune from the sun is 4,500,000,000 kilometers. How is the distance expressed in kilometers? So again, really quickly, big number equals positive exponent. I'm going to put positive exp. If we have a very small number, we should have a negative exponent. So looking here, I see that this is a very big number. I have 4,500,000,000. The fact that this number is very big is telling me that my exponent should be positive. So looking at my answer choices, I know I can automatically eliminate A and B. Now, to figure out my exponent, I'm going to go ahead and rewrite my numbers. So 4,500,000,000. So right now, my decimal, I don't see a decimal here. So since I do not see a decimal, it is out of sight and to the right. So now, I want to place my decimal after the first non-zero number starting from the left. So if I start at the left, I see this number and I have the number 4. Number 4 is a number that is 1 through 9, so I'm going to place my decimal after the number 4. Now I want to see how many times did I move my decimal. So starting off from the very end, I moved my decimal 1, 2, 3, 4, 5, 6, 7, 8, 9 times. I moved my decimal 9 times. So this decimal I can cross out. Here is my new decimal. So when I rewrite this, this is 4.5. I no longer need to include all these zeros times 10. And since I moved my decimal 9 times, my exponent is going to stay 9. And again, since it was a very big number, my exponent is positive. That being said, here my answer choice is going to be C. Let's look at number 2. Number 2 says Gabby is converting 0.000098 into scientific notation as shown below, which correctly represents the missing power of 10. So I'm going to go ahead and start off by first rewriting my number. I have 0. I'm going to change my color to red. I have 0.000098. That was 1, 2, 3, 4. Yeah, 0.00098. So here I automatically see this number is very small. That being said, if I have a very small number, again, that tells me my exponent should be negative, and I can eliminate answer choices A and C because they have positive exponents. So now we need to talk about where we want to place our new decimal. Right now, my decimal is currently placed right here, and I need to place my new decimal after the first non-zero number. So if I start off at the very left, I have 0. I cannot place it after 0. Still cannot place it after 0. Still cannot place it after 0. Still cannot place it here. And I'm now going to place it after my first non-zero number, which is 9. So here this is 9.8. Okay, so this is where my new decimal goes. Now again, I want to see how many times did I move my decimal point from the original location. So starting here, I moved my decimal 1, 2, 3, 4, 5 times. I moved this 5 times, and again, since my number was very small, my exponent here is going to be a negative 5. So here, B is my answer. So that was going from standard to scientific. Now let's go ahead and look at going from scientific to standard. So going from scientific to standard, we're going to look at number 3. It says a biologist measured the diameter of a microbe and found it to be 1.32 times 10 to the negative fifth power meters. How is this number expressed in standard decimal notation? So the first thing I'm going to do is rewrite the number. My number is 1.32. Now, I also want to talk about this exponent of negative 5. That's very important that we pay attention. Since this exponent is negative 5, that tells us that our number should be very small. I should not have a number that is larger than 1. Now, if we look at our answer choices, everything looks small. Everything is smaller than 1. So now, let's go ahead and apply this to our number. So since my exponent is negative 5, remember, however much your exponent is, so here, since my exponent is negative 5, this is telling me that I'm going to move my exponent 5 times. Since I have a negative exponent, this means I move my decimal to the left. So starting off here, I'm moving my decimal 1, 2, 3, 4, 5 times. Here is where my new decimal point goes. And now what goes here are zeros. So here my number is now 0.00000132. So I have 0, 4 zeros, and then 132. So looking at A, I have 0, 1, 2, 3, 4 zeros, and 132. So here, the number that matches is going to be answer choice A. Now let's look at number 4. Number 4 says Olivia is converting 5.5 times 10 to the 8th into standard notation. How is this number expressed in standard notation? So again, I'm going to go ahead and start off by rewriting 5.5. And here I want to pay attention to my exponent. My exponent is a positive 8. So since my exponent is a positive 8, that means that I should have a very big number. Because remember, positive exponents mean big numbers. And since my exponent is positive, this means that I'm going to move my decimal to the right. So starting off at my decimal here, I'm going to move it 8 times to the right since it was positive. So this is 1, 2, 3, 4, 5, 6, 7, 8. So this is where my new decimal place goes, and I can cross this one out. Now what goes here are zeros. So when I rewrite this number, I have 5, 5, and then 1, 2, 3, 4, 5, 6, 7 zeros. 4, 5, 6, 7, and then we want to go ahead and place our commas. So when we place our commas there, every 3 numbers starting from the right. So this is 1, 2, 3, comma, 1, 2, 3, comma, and then 1, 2, 3. So here, my number turns out to be 550 million. And looking at my answer choices, the only one that matches is going to be B. Now, since my exponent was a positive 8, that let us know that we were going to have the big number. So you could have automatically eliminated D, and then you would have been left with your 3 answer choices. But again, that being said, that was scientific notation.